Adab, good evening. Dear Honorable Speaker, research enthusiast participants, welcome to your most expected research idea series. I am Ritushri Modak Shathi, Campus Research Co-Ambassador of গবেষক হতে চাই বি রিসার্চার বিডি platform from Haji Mohammad Danish Science and Technology University. It's my pleasure to host today's program. Before dive into the live session, I'll introduce গবেষক হতে চাই Be Researcher BD platform, its mission, vision and activities. গবেষক হতে চাই Be Researcher BD is an online-based non-profit open platform directed by some world-class scholars. We are tirelessly working to promote research and guide young researchers in Bangladesh. Its vision is to leverage research in higher educational institutes for sustainable development all over the world. This noble effort has been initiated by Mr. Mohammad Sabir Hussain. He is working as an assistant professor at the Department of Computer Science and Engineering CSE of Chittagong University of Engineering and Technology, Chuet, Bangladesh. Universities are the place for knowledge creation and dissemination. However, we know that the universities are going in the traditional way. Although the final year students do their thesis or project for obtaining the certificate, but research and publication at undergraduate level are rare. Mr. Sabir Hossain worked in a different way. By his effort, the second year students of the CSE Department of Chuet have published more than 10 articles in international conferences and journals. This type of accomplishment is rare, but not only in Bangladesh but also in first world universities. Being perplexed by this achievement, he has created this platform to diverge this enthusiasm among all of the students who are interested in higher studies. We assist researchers by sharing research related resources such as books, papers, websites, etc., conducting online or offline training courses, arranging seminars, workshops, or webinars, research collaboration or supervision, arranging internship opportunities. Previously, we have conducted the country's first free complete online training on how to become a researcher. This course covers the basic concepts, tools, and techniques required to become a researcher from zero knowledge. The recorded lectures on YouTube received more than 39,000 views within 10 months only. Then we have started the most demanding online free course titled Python for Research from Any Discipline on 31st April 2021. We know that selecting research ideas is the most important step in research methodology. However, finding a research idea topic is a challenging job for the research enthusiast and new learners. To assist them in finding ideas easily, we are organizing this research idea series. Research scholars from home and abroad of different disciplines will deliver lectures related to his research expertise or domain knowledge. Basically, speakers will share trending research topics, skills, tools, and techniques required to start his or her current and past research projects, publications guidelines for a specific field. We have a plan to cover all possible research areas in future. Now I'm gonna introduce today's session and speaker. It's the 12th lecture of the Research Idea series titled as Optical Wireless Communications and its Role in 5G and Beyond Systems. The key highlights of this lecture are research areas in optical wireless communication, trending research in optical wireless communication, skills, tools, and techniques to start research in optical wireless communication, speakers, past and current research projects, reputed journals and conferences, publication tips, research collaboration opportunities. Today's honorable speaker is Professor Mostafa Jaman Chowdhury, senior member IEEE, received the BSc degree in Electrical and Electronics Engineering from the Khulna University of Engineering and Technology, Kuwait, Bangladesh in 2002, and the MSc and PhD degrees in Electronics Engineering from Kookmin University, South Korea in 2008 and 2012 respectively. In 2003, he joined the Electrical and Electronics Engineering Department, Kuwait, as a lecturer, where he is currently working as a professor. He was a postdoctoral researcher with Kookmin University from 2017 to 2019. He has published around 143 research papers in national and international conferences and journals. In 2008, he received the Excellent Student Award from Kookmin University. His several papers received the Best Paper Award at several international conferences around the world. He was involved in many Korean government projects. His research interests include convergence networks, QoS, quality of service provisioning, small cell networks, Internet of Things, e-health, 5G and beyond communications, and optical wireless communication. He received the Best Reviewer Award 2018 by ICT Express Journal. Moreover, he received the Education and Research Award 2018 given by Bangladesh community in South Korea. He was a TPC chair of the International Workshop on 5G or 6G mobile communications in 2017 and 2018. He was the publicity chair of the International Conference on Artificial Intelligence in Information and Communication 2019, 2020, and 2021. He served as a reviewer for many international journals, including IEEE, Elsevier, Springer, Science Direct, Wiley, MDPI, and Hindwai, published journals, and IEEE conferences. He has been working as an editor for ICT Express, an associate editor of IEEE Access, an associate editor of Frontiers in Communications and Networks, a lead guest editor for wireless communications and mobile computing, and a guest editor for applied sciences. He has served as a TPC member for several IEEE conferences. The lecture will start now. There will be a question answering session after the lecture. You can ask question by commenting on the live program on our page. Now I'm requesting our honorable speaker to start today's lecture. Sir, the floor is yours.
Thank you very much. I am very much excited to deliver this speech, and I am very much thankful to the organizer. They invited me, and I uh, agreed their invitation without any hesitation. So I'm very much happy to deliver this, to get this opportunity. I also give thanks all the organizers who are working for this organization. Today, actually, I will present one technology. Many people they don't know this new technology. Actually, we cannot say very new, but many of our researchers they don't know about this technology. That's why I want to introduce this technology to our community. What is that? That is optical wireless communication. Nowadays we everybody know about the RF communication, optical fiber communication, but many of us we don't know about optical wireless communication. This is one kind of wireless communication, but the medium is optical. And this communication will play a vital role in the 5G and beyond communication. That means 5G, 6G, 7G, 8G. The generation change every 10 years. 1G, 2G, 3G, 4G, 5G. We are now in 4G in Bangladesh, and many countries already deployed 5G. And every 10 years, this generation is changed. So we're expecting that these optical wireless communication systems, there are many, they, uh, they will play a vital role in this 5G and beyond communication system. And this lecture, I will try to I will try to make you understand what is optical wireless communication and how it can play role in 5G and beyond system. So these are the key point that I will discuss in my presentation. Some motivation why we need optical wireless communication, something like this. So network evolution. So I will tell something about first generation to sixth generation technologies, and I will discuss some electromagnetic spectrum, optical wireless communication technologies will be discussed, and I will discuss some research direction for this, and I will conclude this one. And after that, maybe I will little briefly discuss about our research collaboration and some research tip. So, in communication, we must have some fundamental thing. So, that if you come from first generation to fourth generation, fifth generation, what is the actually change? Our change is the application, different application, and this need wide band of multimedia traffic. So day by day, traffic is traffic type is different, traffic volume is different. So it is our requirement. This is requirement of our society, our life. And another thing is seamless communication. We want to move from here, there. So this is another requirement. And another requirement is multi-radio network convergence. If you see around you, there are many kind of communication system. So how to converge them, how to make them integration. This is another issue, and we use the communication in different platform. So sometimes we are in vehicle, sometimes we are in house, sometimes we are in drone, something. So platform is different. So these are the requirement. So how to meet this requirement? We have two ways. One is revolution, another is evolution. Everything has two ways. Another revolution, what is this? You develop something new. And evolution is what is this? There is something existing and you just modify. That is evolution. So you can improve our system. You can reach your goal using both of these way. And when you think about communication system, so it should be very efficient, it should be very reliable, it should be very secure. So if you fail any of them, maybe your communication system will be failed. You cannot reach the goal. So these are the fundamental things. And you know I want to discuss this detailed thing. You know about the father of digital communication, that is Claude Shannon. So in uh, why I'm telling this thing, because he gave some theory, and in his theory, all solution are there. So all hints are there. I'll explain in the next slide. So he gave some theory in 1948, and he wrote one paper that is a mathematical theory of communication. If you search Google, you can find this paper, and this is the you can say very big change in communication system in his theory. And what is he did? You see, he gave one formula. This is Shannon-Hartley theorem. So this is actual wireless communication system. C is the capacity of a system. So we want high data rate. High data rate. If you are using mobile in your home, you today you want 1 megabit per second. 50 up 1 month you will want 100 megabit per second, and after 5 years maybe we will want 1 gigabit per second. So this is C. So how there is some relation with C and other parameter, and all wireless communication, their problem and solution, everything within this equation. I think this is, I think all solution are there, all clue of there. Whatever happen in wireless communication, they try to improve B, they try to improve S, they try to reduce N. So how can you increase C? You can increase B, you can increase S, you can decrease N. So whatever in the wireless communication system, all thing within this one. So many researchers they are working to reducing the noise. Many researchers they are trying to increase B. So all researchers are here. So if you are interested in wireless communication, you must know this equation, and you have to think this equation. And 5G and beyond communication. What is this? This is very exciting. You know that almost every 10 years the generation is changed. Suppose you are in 1994, at that time first generation come. So what is that? AMS, that's name is AMPS, that is Advanced Mobile Phone System. At that time, if you have this phone system, you are very rich man, you are very different, special person in the society. So in that case, you see the what is this? The basic voice and service. This is the application, but at that time, this is used by only some very special person. If you think if your mobile is serve only this thing nowadays, you will not use that phone, right? So your demand is increasing. At 1994 84, the demand was low, just basic voice was served. So that is you are happy. And what has happened in 1996 is second generation, 2000 in third generation, 2010 is fourth generation. What is this? This data rate is 100 megabit per second is mobility, and 1 gigabit per second in when you are in stationary. So in 2020, even though we don't have in Bangladesh fifth generation, but many countries they already have fifth generation communication system. So what is this? Anytime, anywhere, anyone, everyone can use any place, anytime. So it can support up to 10 gigabit per second, and you can apply in virtual reality or augmented reality. So if you just look at from first generation to sixth generation, your demand is increasing. Your to meet that demand, so new generation is coming. You can say why fifth generation we need, because we this is our demand, this is our requirement. So to fulfill the requirement, we need the fourth generation cannot fulfill that demand, so we need fifth generation. So again, there will be some new thing that cannot be provided by fifth generation. So you will have to move to sixth generation. You have to make new thing. You have to deploy new thing. You have to create new thing. Again, maybe after 10 years to 2040, you will have another new thing, another new requirement. So this 6G cannot provide you that demand. So you have to make new thing. So this is the some summary of first generation to sixth generation. So if you see, so as I mentioned, why this generation come? Because of your demand. If you see this global traffic volume in you see 2020, just 62 exabyte per month, but when you will go to in 2030, your demand will be 5016. So your demand is increasing. So if you demand is increase, so you have to have do something to meet the demand. Suppose in your family, your demand is your family demand is suppose monthly demand is 50,000 something, but your income is 10,000. So you have to manage another 40,000 by anyhow any something. So you see, demand is coming in every demand. Whenever you have demand, you have to fulfill that. So is demand is increasing, so you have to because in 2020 you demand, and 2030 demand is almost 100 times. So the network you have in 2020, you cannot meet the demand in 2030. So you have to solve the problem. If you see the traffic volume per subscription, suppose you are a subscriber, you have a mobile in just think 2 years ago, if you buy 1 GB data 1 month, maybe it's okay for you. But now if you buy 10 gigabyte, after 25 days is finished, your data is finished. So if you see in 2020, your demand average demand is 5.3 gigabyte per month, but if you go in 2030, your demand will be 257.1 gigabyte per month. Because why? Because new application is coming. Suppose 1 year, 2 years ago, you never use video conferencing, not much more. But now video is very important issue. So your demand will increase. So if you think about the 6G communication, what is the requirement? Its requirement is ubiquitous mobile ultra broadband, very high speed, and machine type communication. In 6G, machine type one machine will communicate with another machine. It is a huge number of machine type communication will come in 6G, and data density will be very high, and AI will be integrated in communication system, and your throughput will need very high, and energy efficiency will be required very high energy efficiency, and backhaul connectivity. The network supply your home, your access network, that is called backhaul network. You need very high capacity, and data security should be very high. And this is some just comparison among 4G, 5G, and 6G communication. So what is the you see the per device peak data rate in 4G 1 gigabit per second, and in 6G 1 terabits per second. You just imagine in 1 second you can download very big size video. You see, so in latency, this 4G is around 100 millisecond, in 6G 1 millisecond. And another thing is mobility support. 4G can support up to 350 kilometer per hour vehicle. Even though we don't have such high speed vehicle in our country, but many countries in the world, they have a very high speed vehicle. In 6G, you have to support 100 kilometer per hour vehicle, because in 2003 maybe many countries, they will make some very high speed vehicle, so you have to support. So to support this requirement, you have to change, you have to supply the demand. You see, 4G has AI. There is no AI issue in 4G, but 6G is fully AI integrated. So if you look at the difference comparison among 4G, 5G, 6G, it's clear that if you in 6G, you need something new, because if you have resource in 4G, you cannot provide the demand of 6G. So you have to update your system, you have to create new thing, you have to and uh, overcome some limitation of existing system to reach the 6G goal. So in the very beginning, I show you some Shannon capacity theorem, that is C. That is, in that equation there was one term B, bandwidth. So bandwidth comes from electromagnetic spectrum. So more the spectrum, more the bandwidth. So if you look at the electromagnetic spectrum, so you say this is the radio wave. Currently we are using radio wave, and maximum application we use less than 10 gigahertz. See, and 10 gigahertz. Most of our application, they are limited to 10 gigahertz, and there are some millimeter wave and millimeter wave. You see, the optical band. So if you look at the all electromagnetic spectrum, optical, this is very wide, sorry, very wide electromagnetic spectrum. So this is 0.3 terahertz থেকে uh, to I don't know this 30,000 exahertz. This huge bandwidth, huge spectrum, electromagnetic spectrum is still not very much used. So in that Shannon capacity formula, if you change B, so if you change B by this optical band, then you can improve your capacity. This is the one way to improve your capacity. So researchers are moving to use this optical uh, band or other band. So this is one way to improve your capacity. So researchers are nowadays interested in millimeter wave. This is the millimeter wave band, is part of optical band and part of RF band. This combined is terahertz, and another very big spectrum. This is optical. The researchers are nowadays interested to use this spectrum, how to utilize this spectrum for communication, so that you can improve your capacity of the system. Now come to optical wireless communication. What is this? I think you already get got some clue. Optical wireless communication. Optical communication, wireless communication. What is this? Our communication is wireless, but what we use is the communication medium. This is optical light. Light will be used as a communication medium. Previously, we most of the application use RF, but now will use optical band. For this is called, if you use optical band as wireless communication medium, this is called optical wireless communication. Okay, so this is very important issue for researcher, because, for 6G and beyond communication or 5G, a huge number of application will be done using optical wireless communication. So this is very good research issue for our researcher. They can there are many issues to work with this communication system. So and next is, hmm, so I already mentioned why new spectrum. Why? Because currently we use RF, widely used RF, but RF is not sufficient to meet your demand. So you have to move to you have to search for new spectrum, and new spectrum is optical is another spectrum. Millimeter terahertz is another spectrum. So currently we use under 10 gigahertz, and if we can extend this spectrum, then we can improve our throughput capacity. This is the main reason. So, what is the limitation of RF? I already mentioned. It has some strictly regulated. You know that some license issue with the RF band, and this band is comparatively very small. So these are the limitation, and it makes some electromagnetic interference also. So to overcome this RF limitation of RF, we can use optical or other optical band uh, uh, together. Together, you don't need to. You not omit RF, and you will not completely move to optical. You have to use both. So why optical? This optical has some unique advantage. It has some promising feature. So what is that? You can provide very small distance communication. You can provide very high distance communication, even 10,000 kilometer. It can perform indoor, outdoor, both type of service. So it has some very special features. So, what are the limitations of optical wireless communication? Your it is the very sensitive of blocking. You know, light. If you have light and it is light, and if you have blocking, so this cannot go through this blocking. This is the problem. Another limitation is its transmitted power is not very high, and its performance is affected by some other light source. So if you have in your room, if you have light source for communication, and another source maybe make some problem. So what is the effective solution? You have to use both RF and optical coexistence together. So if you use both together, so you can overcome the limitation of both technology, and you can get the benefit of both technology. Now come to the point. What are the optical wireless communication technology? There are many. There are mainly uh, four optical wireless communication technologies. One is visible light communication. Maybe many of you know this term, but maybe you don't know. Another term is Li-Fi, light fidelity. Everybody you know about Wi-Fi, right? So Wi-Fi and Li-Fi similar. Okay, Wi-Fi is Wi-Fi, and Li-Fi is similar term and name also similar. Light fidelity and wireless fidelity is Wi-Fi. So their functionality is similar. Another is optical camera communication, and another is free space optical communication. In visible light communication, you use visible light. You have light visible, you can see that light is used as your communication medium. In your room you have light, you don't need to use Wi-Fi. Your laptop or can be connected with that light, and you can get internet. So Li-Fi also something similar to VLC, but there are some difference. I will discuss later. This is you use light and Wi-Fi functionality together. That is called Li-Fi. Light, you have to use light as well as some wireless Wi-Fi functionality. What is the this one maybe use visible light or maybe not visible light. Light, there are many three kinds of light: visible light, infrared, ultraviolet, three types. So VLC you must use visible light, but Li-Fi maybe use visible or another. Optical communication, in this is very interesting. And your camera, you have camera in your mobile, you have camera, you use this camera as communication receiver. Okay, in using camera you use communication. And free space optical communication, in free space there is some light beam, you use that light beam for very long distance, you can communicate this free space optical communication. And why optical wireless communication for 5G and beyond system? I already mentioned that 5G and beyond system, they need very high data rate, high security, very low latency, something like this. And all these things can be provided by this different optical wireless communication. Different optical technology can support different feature, so that can meet the demand of 5G and beyond communication system. Suppose we are going to internet of thing, right? Internet of thing, and next time we are coming for internet of everything. So if you have LED in your home, in our home there are many devices, they have LED. So this LED can be used for your Internet of Thing purpose. So this is also optical wireless communication. Nowadays, for IoT purpose, we normally use Bluetooth type of devices. But we can also use LED, our home LED, for this communication purpose. So this can also provide the support for Internet of Things. So optical wireless communication, what are the application? This is some example. You can use healthcare, railway station, transportation, home, office, shopping malls, underwater, space, and whatever. Every place you can use the optical wireless communication system. Uh, So what are the platform? You can use device to device communication, machine to machine communication, even one chip inside chip, one chip to another chip. You don't need to connect by conductor. You can use the optical connection, wireless connection, and machine to user. In vehicular communication, nowadays we are using RF system for vehicular communication, but we can also use optical wireless communication for vehicular systems. Even you can use point to point communication, multi point to point to multi point. And this shows that in every places, every field, all application, we can use optical wireless communication. So nowadays we are mostly use RF, and there is some scope to use optical wireless communication for those application. because you know that if you use too many RF, maybe it make a lot of interference, some problem. And if you use the optical wireless communication along with this RF, you can minimize many problem. So this is one application just I just show. This is you can use even in satellite link. You can use in optical connector as optical connector. You can use as body area network, or you can use wireless LAN type communication. All kind of communication can be performed use optical wireless communication. So this is also another application. You say you have suppose on our campus we have many building. We normally connect one building to another building using optical fiber. You don't need. You can use the free space optical just light and communicate. You can use one satellite to satellite, satellite to ground, and even vehicular communication. Even in your body, you can communicate using optical wireless communication. That's mean you have wide range of application of optical wireless communication, and this current application can be replaced. All or few can be replaced by optical wireless communication. Optical wireless communication category, I mentioned here that optical wireless there are three uh, uh, we can divide: infrared, visible light, ultraviolet. So this three band can be used in different purposes. Suppose communication, Li-Fi, OCC, FSO. This can use infrared, and BLC, Li-Fi, OCC, FSO they can use visible light, and ultraviolet can be used by Li-Fi or FSO. Even though ultraviolet some negative some problem, but we can use. We can if we can overcome that limitation, maybe this will be also good. So you can also even previously I mentioned that wireless communication there is problem with blockage of obstacle. Even you can use optical wireless communication for non-line of sight communication. You know, this transmitter receiver they are not in a line of sight, they are non-line of sight. Even you can use for optical wireless communication can be used for non-line of sight communication also. So you see this transmitter and this transmitter in two building, they far distance. There are some building inside this, but even though you can use this optical wireless communication using ultraviolet. So this is a promising feature of optical wireless communication. This how ultraviolet principle, you know that in our ethernet system, uh, there is some you saw what is this. Sorry. So in transmitter and receiver, they create a path using ultraviolet and they can communicate. So in optical wireless communication, as a transmitter, you can use LED light emitting diode or laser diode. So there are some advantages and disadvantages of both. So what happens if you use laser diode? What happen in LED? You know, in a laser diode, the light are coherent. This light concentration is very high, but LED uh, this little bit spread and it cannot go very little higher distance. But LED in your home, you already use LED light. LED is something. So this LED can be used. So both of them have some advantage and disadvantage. I will discuss. So if you use light emitting diode in the optical wireless communication, so what is the advantage? So LED can change very fast. Okay. So if it more fast, your communication will be more fast. So LED can change very fast. So you can its modulation can be very high. And our home, normally nowadays there is a trend to replace the incandescent and fluorescent lamp with high intensity solid state white LEDs. So these LEDs we can use. We already have LEDs. So this you don't need to buy new. So this existing infrastructure you can use. And LEDs are very high efficient, longer lifespan, low heat generation, reduce uses of harmful material in design and color interpretation without using harmful chemical. And as I mentioned, the LEDs can switch very high speed. That is very important issue for high speed communication. And it can be served for illumination as well as communication. This is the most important advantage. But LEDs has limitation, as I mentioned. This light no incoherent, so it cannot go very high long distance. And this light is not very strong. That's why another light source can cause interference. So why I am telling about advantage and disadvantage? So there are some limitation. If there is some limitation, there is a scope of research. If you can research, you can provide some solution of this limitation. You can publish paper. You can write journal paper. And laser diode has some advantage. Its light is very high concentration. It can go very long distance. It can go very long distance, and its power is high. And laser diode has disadvantage. Its low aperture. I mean, so if there is some communication through point, this should be very I mean pointing should be very tight, otherwise your communication will be a problem. And laser diode has some health threats also. This is another issue. Optical wireless communication, there you see this block diagram. You have encoder, line coding, modulation, all same, but based on physical transmitter and receiver and channel, all four communication are divided. For example, VLC, Li-Fi, OCC, and FSO. This is because of these three things. So this is for uplink and downlink. What is the difference between VLC, Li-Fi, OCC, FSO? Which for which technology, what type of channel, what type of transmitter, what type of receiver we use? This is given here. So you see that OCC use camera, but Li-Fi use PD as receiver. VLC use camera or PD. So these are some difference. There are some difference. I'll in the next 2 or 3 slide I'll explain little bit. So what is VLC? So VLC, as I mentioned, this communication medium is visible light. Okay, so it can be either point to point, point to multi-point, or multi-point to point. So there are some one unique characteristic of VLC. The communication medium must be visible light, and it has some limitation because if you have LED or PD has some limitation because outdoor application, this is not very effective, and it cannot perform long distance because of LED and PD. So we deploy OCC. So in VLC, you can also apply in different field of our life: smart lighting, V2X, hospital, aviation, underwater communication, many field of application. Li-Fi, Li-Fi is also based on optical wireless communication, in which what is happen, transmitter you have to use LED, and receiver you have to use photo detector. But in here is the visible light in forward path, and return path you can use infrared, visible light, or ultraviolet, any kind of this. But what was in visible light, you have to use always visible light. So Li-Fi has some unique characteristic. It is must be bi-directional communication. It must provide seamless user mobility. That's mean your Wi-Fi has those feature. You should have all these feature. Wi-Fi provide bi-directional communication, point to multi-point communication, all features of Wi-Fi. And if I compare between Li-Fi and VLC, so I already mentioned VLC must use visible light, but for Li-Fi this is not mandatory. Sometimes if a Li-Fi system use visible light communication, visible light as medium, you can see this system as visible light. Okay, and one visible light communication system that is bidirectional, point to multi-point, that VLC system you can say this is a Li-Fi system. Okay, so this is there is some difference. Many people they don't know the difference, they just confused. So this is the architecture for OCC, Li-Fi, and VLC system. So you see LED light, laser light, these are connected, and these are connected with gateway and backhaul network, and then connected to core network. So Li-Fi VLC application, you are inside in a meeting, you don't need Wi-Fi. You have light in your system. From the light, you can receive data, you can transmit data. You are studying in a lamp. This lamp is used as your Wi-Fi kind of Wi-Fi. In the in the vehicular communication system, you can communicate with vehicle to vehicle, and some user he's under the light, he use this light as communication. There are some I told you Wi-Fi and Li-Fi, they are similar technology. One is RF, another is optical. So there are some difference. I mentioned this. Their functionality is same, but there has some difference. One is RF, and another is Li-Fi is optical. And their Li-Fi, this one data rate is 10 gigabit per second now, and Wi-Fi until now is 6 gigabit per second. So Li-Fi can provide higher data rate. Optical communication, this is just one directional communication, downlink. So in OCC you use LED as transmitter, camera as receiver, and communication media you use infrared or visible light. So you have difference between OCC and VLC. What is that? OCC use must use camera, but for VLC this is not mandatory. He can use camera, or he can use it can use camera, or it can use photo detector. So what is the unique characteristics of OCC? It must use camera as receiver. So as I mentioned before, LED PD based VLC Li-Fi system has some problem because what? Because LED light cannot go long distance. It can be interfere with by other light source. So we use camera as receiver. So if you use camera as receiver, then what happen? Your external light source cannot interfere your transmitted light very much, because camera, what is this? If you just in camera, you can capture the image. You can produce the you can reproduce the data. So this is in OCC, optical camera communication. So this is your camera. Inside camera there is image sensor. There is some light source. This light source, light image is fallen in the image sensor. So in this image sensor, you can the light source image, you can detect whether this is 101010 something like this. So if even though you have three light source, you can get three data separately. And even though you have some noise, ambient noise, some sound, but you can easily separate them. This is very important to separate the noise and signal. So you can separate the signal and noise. I think we don't have very much more time, so I'm little bit fast. So, Shati, what is the time limit? Is there any time limit? Is there any time limit for this presentation? Uh,
No, sir.
okay. Maybe
Sir, you continue.
I have little bit. Okay. So OCC application, you see, if you go some digital signage, your mobile just uh, look at like this, you can get all information. Nowadays we have some scanning, right? So instead of scanning some barcode, you can scan some led information. So you capture in your mobile, you can get information. If you go some shopping mall, you can get if you have some light source, led light, or any in a in light tag. Normally now we use sensor tag. We if you use some light tag, in that tag you can get some data. You can use camera as the receiver. In the outdoor vehicle to vehicle, you can communicate using OCC system. So OCC have wide range of application also. So what is the advantage? It is non-interference communication, high signal to noise ratio, and you don't need complex signal processing. And communication distance, with the communication distance, is its communication is stable, but there is some still problem, blocking of optical link, and data rate is very low. This is the important research issue for OCC is rate is low. If you can improve the data rate, you can publish very good journal paper. If you give some idea how to improve the data rate. Actually, why the data rate is low? Because of our camera frame rate. Camera frame rate, the camera frame rate is a little bit low. That's why data rate is low. So if you buy very high frame rate camera, this is very expensive. So if you can give some theory, if you can give some idea how to improve the data rate, you can publish. I guarantee you can publish very good quality journal paper. And light flickering, the light, because light we use for communication. Sometimes if light is flicker, that is not good for our eye. So OCC you can also application in different sectors, V2X into a positioning, digital signage, drone-to-drone communication, augmented virtual reality. You have to remember that since the OCC data rate is low, you cannot apply in high data rate communication. For positioning, you don't need very high data rate, so you can use easily. And free space optical communication, this is, you can use very long range communication, is use laser diode technology. You launch a very high power laser light, and it can go through several thousand kilometers. So you can communicate several thousand kilometer distance using FSO system. It normally use near infrared spectrum, but you can also use visual light, ultraviolet. But this is rarely used, or maybe not used, but it is possible to use. Another important issue is attenuation. Is attenuation is important issue. This in FSO system, if you this attenuation is dependent on weather condition. You understand? If you have some foggy condition, it's problem. If there is some snow condition, this is a problem. So if you do research on this, sorry, so this area, if you design some system how to overcome the attenuation in snow condition, how to reduce the attenuation is foggy condition, you can have very good paper. So what are the application of advantage of FSO system? A very high bandwidth. Your data rate is very high. It can be deployed very easily. Suppose if you want to deploy optical fiber link, it's very expensive and time consuming. But FSO, you can easily deploy in any place. Suppose any emergency condition, you can deploy. But it also have limitation. I already mentioned link reliability, especially long range. It's sensitive about weather condition, rain, haze, smoke, sandstorm, cloud, snow, scintillation, that can increase the attenuation, because our weather condition is continuously change. That's make the attenuation is changeable attenuation. That is the limitation of FSOC system. Even you have one FSO link and one bird is flying. Bird is flying, and there is some interruption. There will be some interruption. You can use FSO system. You see that one building to another building, one chip inside the chip, one chip to another chip connection. You can use underwater communication link. You can use one base station to another base station. You can use satellite to satellite link, different link using free space optical communication. So this is the RF technology is microwave link, and optical technology FSO link. These are two complementary technology, FSO and microwave similar, and microwave is based on RF and FSO is based on optical. So in compared to microwave, FSO can provide more communication distance, and also data rate is higher, and interference is low. Environment impact is high. If you have some advantage, you also have some disadvantage. So if you can provide some solution how to reduce the environmental impact, this is you can publish good paper. So these are the issue for this communication. So I will discuss some open issue that you can work with this optical wireless communication, and what is the future research direction. One thing is hybrid network architecture. What is hybrid network architecture? I mentioned you have to you can use both RF and optical. So if you use two technology together, so what will be the network architecture? What will be efficient network architecture? How to minimize the cost? These are the some uh, research issue for you who want to work on optical wireless communication. And sometimes you have to smoothly switch from one technology to another technology, so how to make it very smoothly. So these are the research issue. And data rate or optical backhaul, I mentioned you, in your building maybe there are 10, 20 wi-fi many system, but a connection come from outside to your building, so that line should be very high data rate. If that is not supported high data rate, you cannot provide high data rate at your home. So this is one issue, how to improve the optical backhaul network uh, data rate, research issue. And another issue I have told you, non line of sight ultraviolet communication. This is actually, this communication system is not fully developed yet. There is many scope to work with this issue. This communication is still not very high data rate. How to improve the data rate, how to reduce the cost, how to reduce the ultraviolet effect. So these are the issue you can work. Another is intercell interference. If you use many LED at your home, so maybe one LED interfere another LED system. So this is you can work in this topic, how to reduce the intercell interference in Li-Fi VLC system. And optical spectrum, I told you, you have a very wide spectrum of optical band. So all optical band are not used yet, properly used. So how to efficiently you extend that band? This is very important issue. And underwater wireless communication, nowadays underwater optical wireless communication is very important issue. We want to search some oil investigation or some many investigation purpose, we use underwater communication. So this still now underwater communication, you cannot, this range is not very high. If you increase very high, the data rate is very low. So and so how to increase the extend the distance, this is important issue. Another issue is how to improve the data rate. So these two you can work for the underwater wireless communication. And seamless mobility, I mentioned, if seamless mean you are moving from one network to another network, so there will be no disturbance. But your cell is very small in 5G and 6G, and support this seamless mobility is very challenging work, and you can work with this issue for your research. And atmospheric loss, I mentioned here, for outdoor case, OWC is challenging. So how to reduce the atmospheric loss in outdoor cases? So this is, you can work. There are many issues with this. You can work with this. Another issue is MIMO optical wireless communication. In RF, MIMO is comparatively easy, but optical system MIMO is little bit challenging. So you can take this challenge in your research. In vehicular communication, nowadays our vehicular system use RF system. You can replace the OW system in vehicular communication, and the vehicle are moving system. So for moving system, little bit challenging to communicate with using optical medium. And for positioning system, nowadays we use sensor for Bluetooth for the positioning, but we can use optical positioning based on optical communication system. So you can do research on this issue. In drone application, you can apply optical wireless communication and precise localization, reliable communication, and how can achieve this thing. You can work on this. Previously, I mentioned that data rate of OCC system is not very high, so you can take this challenge in your work how to improve the data rate. And another, there is a one clue in LED. It can be used. It can make red, green, and blue light, and these three different color can be used to improve the data rate. Dimming control is the brightness. Because of communication, maybe your brightness is reduced. So this is even though you communicate a light source and lighting both purpose, so your dimming is not reduced. So you can take you can work with this issue. This is also one issue, research issue. And last one is flickering avoidance. For especially for optical camera communication, this is little bit low what is this frame rate. It can make some flickering. I mean, if some light is, our LED is always on off, so it our eye detect that, that is called flickering. That is not good for our eye, and we are not convenient with that. So how to avoid this flickering, this is also a very important and promising research issue. And in the conclusion, I have to say that each generation is change, and it bring new and exciting feature. Why we need a new generation? Because of demand. Because of demand, and you have to change one generation to another change. And 5G is already officially launched in 2020 in many countries, and it has many important impressive feature. And we are looking for 6G, and it will be deployed in 2027 to 2030. This is expected. And this 5G, this is not able to support the 6G. That's why we will need a new thing. And optical wireless communication will play a vital role in 5G and beyond communication system. And still, there are many issues that need to be solved, and we have many scope to work with this research topic. Thank you very much. Last of all, maybe my slide. This is actually based on some of my published work. You can see some relevant paper. These are relevant paper of optical wireless. All are optical wireless communication. OCC, you see the optical camera communication. This is 6G wireless communication, and this one is 5G e-health optical camera communication, optical wireless hybrid networks, and this one is Li-Fi OCC hybrid system. This one is optical wireless communication. All these are some optical communication related, wireless communication related papers, and this yellow highlight. These are the most important paper. If you read this paper, I believe you can understand what is OWC, what is the prospect of OWC, what are the application. You can understand details about this thing, and you can find some challenges if you read these yellow mark papers. And most important paper is number 17. Number 17 is the most important paper. If you really want to know about optical wireless communication, first I will ask you to read this number 17 paper, and if you time, then 9, 6 and 4. This 4 paper, if you read, you will get a lot of knowledge about 6G, lot of knowledge about optical wireless communication system. And other paper, you can also have some issue about optical wireless communication. And if you see that my papers, this 4 paper I mentioned, this one is just published in 2018, and almost 300 citation it has gotten, and 6 paper it published in 2020, and it has 213 citation, and you will be happy that in the journal this paper is the most popular article in that journal. So many people read this paper, and this paper was published in 2019, and this paper is published in 2020. This fourth paper, if you read, you can. I believe you will not. You will have all the information of optical wireless communication. And the organizer asked me about research collaboration and opportunity. Actually, I am always very much welcome everyone if someone is really interested. Many students they show some interest, but not real interest. If someone really interested with work with me, you don't need to put my name in your paper. You can get my help. Okay, I can help you without any hesitation. You can you can contact me. And if you want some even what is this academic degree, you can admit my university. You can work for masters, PhD, or even distance collaboration, whatever. You are welcome. So because if you want to collaborate me, maybe you need to know about me. I'm professor at Kuwait. You already know. The I was postdoc researcher in Korea in 2000, between 2017 and 2019. I my education is here. You can get my information about my profile here. Uh, and my interest is 5G and beyond communication. This is you can work on a small cell network, cellular network, optical wireless communication, vehicular communication. I am interested mainly focusing on network architecture, interference management, mobility management, integration, integrating heterogeneous networks, AI-based future wireless communication, and hybrid communication. These are my specific focus. If you really want to collaborate me, work with me, if you are interested with this topic, you can work with me and you can contact with me. You are welcome. And finally, the organizer asked me to give some tips about publication. Actually, I already spent a very long time. Maybe this is already more than 1 hour. I'll give very brief tips about the publication. So, what are the basic requirement for the research? You need some fresh mind. You understand? Fresh mind. Normally, if you, I was in Korea for a long time. They give a lot of opportunity for a student to go amusement park, to go some good place. You understand? To fresh your mind. Your mind should be fresh. You have to think. If your mind is not fresh, you cannot think new thing. You have to work very hard, and you have to select some potential supervisor, and you must remember some ethical issue, because you are very beginner, many student you are very beginner. If you make some fault in the beginning, it may cost huge for your life. So please remember the ethical issues, and you should be honest in research. And I suggest you focus on quality, not quantity. Maybe in the beginning there is some quantity is important, one or two, but if you have some little quantity, then you must focus on quality. Quality is important. If you have 100 papers publication but not quality, and another one has one publication is quality full, that is more weight. You understand? And when you have a plan for publication, so what thing you have to consider? Spot on trend and hot issue. If you really want some publication, you have to find out what is the hot issue, what is the demand. You have to find out. If you work on new issue, that is good to publish paper. Try. If you there is very new issue, maybe initially you have some difficulty to find out some related paper, but if this is new issue, then comparatively easy to publish paper. Then you have to find the problem identification. You have to find the problem. What is the problem of this system? To solve this problem, you have to give some idea. Maybe this idea can solve this problem, and then you have to think how your idea can overcome existing limitation. Maybe there are many many solution, but and there are many limitations. So maybe how your idea can overcome the existing limitation, you have to you have to think about that. You have to find out that. And if there is no existing system, maybe you have to focus what is the new opportunity of your idea, if this is very new. And you have to give the system model of your idea, what is how it works, something like this. And finally you have to validate your work using some performance analysis, something like this. If you publish some paper in a magazine or survey or something, sometime you don't need this validation. Okay, but this yellow color point is these are must needed. Sorry, I just want to tell about two important ethical issues. One is authorship, another is plagiarism. Please very carefully think about these two things. I saw many paper. There are many author, many author. Everyone can say that there is maybe some student or some author they don't have any contribution, but his her name is there, and this is not good for your future. So but there is no universal definition of authorship. Okay, but you should be very honest about this. So please be careful when you name in another paper, and please be careful when others name you put in your paper without any contribution. Please you name in other paper not good, without any contribution, other name in your paper also not good. This is the author should take responsibility to certify that the manuscript represent valid work. So if any work cannot certify that, he should not be the author. You understand? So author is usually involved in drafting or revising the manuscript, as well as approving the submitting manuscript. And sometimes we write a paper and I give this one to my friend. Please see this one. Is there any a language problem, something like this, and give his name in the paper. Actually, this is not good. So you see, data collection, editing of grammar. There are many English grammar company. They check your grammar. So there are so they also check your grammar. So editing of grammar, language, and other routine work by itself do not deserve an authorship. Please remember this. And redundancy, same paper in many in different format you publish. This is not good for your future. When you apply for some position, they will check your publication. If they see that same thing you repeat, they will have bad impression on you. Thank you very much for your listening.
Thank you,
Is there
sir,
any
for your
question?
thank you, sir, for your wonderful and motivating speech. Hope that it will be helpful for all of the participants. Now, I'll read out question from the comment box. There is a comment from Mahmudul Hassan. He asked, "How can we deliver so much BW in 5G to subscribers as BW is very costly?"
No. If you use optical band, that is not costly. Optical band is free. That's why we are moving to optical band. I told you RF is there is some regulation license issue. For optical case there is no license issue. It's free, so you can use.
And there is
I
another comment from Mohammad Sabir Hossain sir. Heartiest thanks to Professor Dr. Mustafa Jaman Chaudhuri sir for managing time busy schedule. You showed the research opportunities in 5G and beyond technologies very clearly. Is there any scope to use data science or machine learning in above mentioned area?
yeah. You can use machine learning is very important issue in optical wireless communication. Many if you find many researchers they are using machine learning for optical wireless communication, because you know that you have to what is this even especially in noisy environment you have to find the real transmitting light. So to separate the light and noise, you can use different method, and machine learning is very important tool in optical wireless communication.
Sir, there is another comment from Mahmudul Hassan. He asked, "Sir, how can we simulations to see whether data rate is improved in OCC and FSOC by changing some parameters? Is there any free software?"
You can use MATLAB, and you have to develop the equation, and you can solve that those equation using MATLAB. MATLAB is the best one.
There is another comment from Naim Riaz Bhaya. He asked, "Sir, isn't VLC vulnerable to light pollution or other light source?"
Your room has light. My room has light. You understand? You already have a light. So I don't know how vulnerable to light pollution. You already have light. Your car, your car vehicle already have light. So you don't need to extra light. Very limited number of extra light. So this is not vulnerable.
Thank you, sir.
You got my answer?
Yes, sir. There is another comment from Mahmudul Hassan. He said, "Thanks, sir."
Yeah, I saw. Thank you. Welcome.
Sir, thanks again
Thank
for
you
your
also.
valuable time.
Thank you very much.
Um, Also, thanks to the
I wish
audience for your participation.
I wish all your get success in your life as well research. Thank you very much. Uh,
Thank you, sir.
Hopefully, we will meet in some conferences and also in some community. We will meet, inshallah.
Thank you, sir. Keep us in your
I-
prayer.
I- yeah, if you have any question or any discussion, you can communicate me anytime. Okay, anytime.
Sure, sir.
Anytime means of course suitable time. You can communicate me, sir. Life accommodation supported equipment very costly. Uh, Not costly. You have some very few equipment in there. This is not costly. When you will have wide number of use, this will be not costly. Now in research level, so maybe now costly, but when it will be widely used, it will not costly.
Sir, thanks again for your valuable time. Also, thanks to the audience for your participation. There is an announcement. Our next research idea series 13 will be held soon. To get updates of our activities, follow our page, join our group, and subscribe to our YouTube channel. We are happy to inform you that we are now a family of nearly 39,000 members, including groups, pages, channels, and LinkedIn pages. In a very short time, stay with গবেষক হতে চাই be researcher BD and invite your research enthusiast friends to our platform. Thank you for being with us. Wish you all success and good health. Goodbye.